The summer of 1942 marked a turning point for the German war industry. Armored units were in desperate need of heavy artillery support, capable of taking out field fortifications and enemy armor at long range. As Soviet defenses stiffened, standard tanks with their 75mm guns could no longer meet the demands of the Eastern Front. Design engineers were given a clear directive: create a self-propelled gun mounted with a 150mm howitzer. The main engineering challenge was mounting such a massive gun on a mobile chassis without sacrificing weight and maneuverability. They decided to use a hybrid platform, combining components from both the Panzer III and Panzer IV tanks. This avoided the need to design a chassis from scratch and sped up production by using proven, mass-produced parts. The resulting unified base, known as the GI Schutzwagen 3-4, became the foundation for the new vehicle. A key design feature was moving the 300-horsepower Maybach engine to the center of the hull. This layout freed up space at the rear to mount the massive artillery system and accommodate the crew. By late 1942, the first units rolled off the assembly line at the Alket plant. The mounted 150mm SFH-18 howitzer had a range of over 8 miles, allowing it to strike targets well beyond the line of sight. With a firing height of 7.5 feet, the vehicle maintained a relatively low silhouette. An open-topped armored fighting compartment protected the 6-man crew from shrapnel and small arms fire, with armor 1.2 inches thick on the front and 0.8 inches on the sides. While the vehicle had a complex designation in official documents, the troops simply called it the Hummel, the Bumblebee. The self-propelled gun's main advantage was its immense firepower. Its 95-pound shells packed a massive, high-explosive punch. The shockwave and shrapnel could cripple light armor, while a direct hit posed a lethal threat to most tanks of the era, including the Soviet T-34. Despite its impressive firepower, the design had a major operational flaw: a limited ammunition load of just 18 rounds. During intense area bombardment, this supply would run out quickly, drastically reducing the vehicle's combat effectiveness. To solve the supply problem, specialized ammunition carriers were developed on the same chassis. From the outside, these looked like standard self-propelled guns, but inside the fighting compartment, the gun was replaced by additional racks for shells. Operational protocol called for one carrier assigned to every platoon of 4 guns to ensure rapid resupply in the field. Deutsche Werke began producing ammunition carriers, but it soon became clear that their manufacturing capacity couldn't fully meet the plan. The GI Schutzwagen 3-4 chassis was in high demand for both the production of the Hummels self-propelled artillery and the Nashorn tank destroyers armed with the 88mm gun. After about 150 carriers were built, production was shut down, but the designers had foreseen the possibility of repurposing the vehicles. Their engineering solution allowed a howitzer to be installed in very short order, even out in the field by maintenance crews, turning a support vehicle into a full-fledged combat unit. By the spring of 1943, the industry had mastered serial production of these new SPGs, and the hardware started reaching the troops. The machines were distributed based on priority. The most combat-ready units received them first, including the SS Panzer divisions. This was a matter of tactical necessity, as ordinary infantry units often lacked the qualifications to operate such complex machinery. Furthermore, the pace of motorized advances required artillery that could keep up with the tanks, whereas towed guns simply fell behind during maneuvers. The Hummel was designed to solve the problem of mobile artillery support. Its maximum highway speed reached 26 miles per hour, allowing the vehicle to move at the same pace as the tank groups. The combat weight was 26 tons, which matched the capabilities of the chassis developed from medium tanks. Ground pressure was 12 pounds per square inch, ensuring it could handle terrain where heavier vehicles might struggle. The self-propelled gun was over 23 feet long, nearly 10 feet wide, and reached a height of 9.2 feet. A clearance of 16 inches allowed it to tackle rough terrain, although crews had to be careful when crossing trenches and craters. The machine was capable of fording streams up to 3.3 feet deep, crossing ditches 7.4 feet wide, and clearing vertical obstacles up to 24 inches high. It could handle a 30-degree incline, giving it the ability to take up positions on high ground. Its range on the highway was 134 miles, while on cross-country terrain that figure dropped to 80 miles. The carbureted Maybach engine was known for high fuel consumption, which put a strain on the supply chain. The fuel tanks held enough for a single day's march, after which refueling was required. During operations, drivers tried to save fuel by using specific engine modes, but in combat situations, maneuvering speed and quickly taking firing positions took priority. The vehicle's crew consisted of 6 men with clearly defined roles. The commander was stationed in the superstructure to the right of the gun, managing the squad. The gunner sat on the left, responsible for firing and working the sights. 2 loaders maintained the rate of fire, handling the shells and charges. The driver was positioned in the front of the hull near the transmission, while the radio operator handled external communications. The effectiveness of the self-propelled gun depended directly on the skill and coordination of the crew. A prepared crew could deliver a rate of fire of up to 4 rounds per minute, a significant figure for an artillery system of this caliber. The Hummels auxiliary armament included a 7.92mm MG-34 machine gun with 600 rounds of ammunition, designed for protection against infantry. The main weapon was the 150mm SFH-18 howitzer, with a barrel length of 30 calibers. This gun was adapted for mounting on a self-propelled chassis and equipped with a reinforced recoil mechanism. The traverse angles allowed for firing at targets in the forward sector, whereas shooting in other directions required turning the entire hull. The vehicle's armor was limited. The 1.2-inch front plate was set at a rational angle, which increased its protective qualities. The sides and rear were covered by 0.8-inch plates, capable of stopping rifle-caliber bullets and light shrapnel. The fighting compartment's superstructure had armor just 0.4 inches thick. The open-top design made the crew vulnerable to high-angle artillery and mortar fire. Engineers were aware of these characteristics, but increasing the thickness of the superstructure plates was impossible due to the risk of critically overloading the chassis. During the design phase, priority was given to mobility at the expense of protection. The front-mounted engine allowed for a lower fighting compartment and accommodated the gun, but it created certain operational quirks. The driver and radio operator sat right next to the engine, which was a source of significant noise and heat. In the summer, temperatures in the driver's compartment could reach 122 degrees Fahrenheit, while in winter, the open fighting compartment suffered from freezing temperatures and drafts. Because exhaust gases would leak into the vehicle, crews periodically wore gas masks during long marches. Production of the Hummel continued until the end of 1944. According to various sources, between 666 and 724 units were produced. The exact number is difficult to determine due to issues with reporting and documentation during the war's final stages. Some ammunition carriers were converted into self-propelled guns right in the field, which also affects the statistical data. This type of equipment was in high demand within panzer divisions that needed mobile heavy artillery support. The first large-scale use of these self-propelled guns took place during the Battle of Kursk. Operation Citadel was viewed by command as a crucial offensive action intended to turn the tide on the Eastern Front. The units involved included these new vehicles, with crews that had undergone training at proving grounds. With the start of the offensive, On July 5, 1943, the self-propelled howitzers were used to neutralize anti-tank defenses, which consisted of an extensive network of fortified positions. Camouflaged 45mm anti-tank guns posed a threat to advancing armor. Hummel crews fired from a distance of 5 to 6 miles, destroying targets before the enemy could return fire. The opposing forces identified the new SPGs as priority targets, tasking artillery reconnaissance with rapidly locating their positions for massive strikes. The key advantage of self-propelled systems over towed artillery was mobility. After completing a fire mission, the vehicles changed location, avoiding counter-battery fire. Drivers used the terrain and tree lines to mask their maneuvers. The typical tactic employed looked like this. The self-propelled gun would move to a pre-scouted firing position, fire 4 to 8 rounds at an area, and immediately pull back into cover. The whole cycle took no more than 5 minutes, minimizing the risk of a retaliatory strike from Soviet artillery. However, the German offensive operations stalled, despite the technical characteristics of the machinery. The opposing side had organized a defense in depth that the armored units failed to break through. Ammunition was burned through rapidly, and logistics couldn't always handle the resupply of shells. The crews faced immense physical strain from manually loading the heavy projectiles. In a number of cases, command made the decision to use self-propelled guns for direct fire against tanks, something that went against their standard tactical designation. The howitzer wasn't equipped with special sights for engaging armor, but the 150mm caliber provided high destructive power. A direct hit resulted in the destruction of heavy KV tanks, while the blast wave from a near miss with a high explosive shell could disable medium T-34s. After the Battle of Kursk ended, German troops shifted to the defense, which changed the tactics for using these machines. The vehicles were used to support counterattacks and cover the retreat of infantry and tank units. Artillery fire on advancing columns inflicted damage on the enemy, forcing the Red Army Command to deploy their own artillery assets to suppress the firing points. Crews often held their positions to the very last, ensuring the withdrawal of other units. A significant portion of vehicle losses wasn't caused by combat, but by technical failures and fuel shortages. Repair crews restored machines in field conditions, but wear and tear on the equipment steadily increased. In the fall and winter of 1943, combat operations shifted to right bank Ukraine. Soviet troops forced the Dnieper and established bridgeheads on the west bank. In the area of one such bridgehead, the German command committed available reserves to eliminate the breakthrough. The self-propelled guns participated in counterattacks, firing on engineering structures from maximum range while staying out of the kill zone of enemy field artillery. Fire correction was carried out by forward observers via radio. Shooting efficiency depended on coordination. Interruptions in communication led to misses and wasted ammunition. The winter period complicated the operation of the equipment. Carbureted engines required long warm-ups, tracks froze to the ground, and transmission oil turned thick. The open fighting compartment offered the crews no protection from low temperatures and wind. Attempts to use canvas tarps proved ineffective, as they interfered with servicing the gun and were damaged by the muzzle blast during firing. Personnel had to rely on winter uniforms, yet cases of frostbite were recorded regularly. By the spring of 1944, the front line had stabilized, and both sides were preparing for future actions. German industry continued producing self-propelled howitzers, though production volumes were dropping due to Allied air raids. The arrival of every new unit of equipment was seen as a vital boost to combat capability. Command tried to save the self-propelled guns for use on critical sectors of the front. Nevertheless, the operational situation was becoming more complex. Soviet troops were concentrating forces for a summer offensive, and the German command viewed the prospects of holding their defensive lines as extremely grim. Hummels' self-propelled artillery guns were actively used for fire support in the difficult combat conditions of that period. In the summer of 1944, during Operation Bagration, Soviet troops defeated Army Group Center, forcing German forces to retreat westward. During the withdrawal, the self-propelled howitzers operated as part of the rearguard of tank divisions, holding back the advance of Red Army units. On the forest roads of Belarus, the vehicles often became targets for IL-2 attack aircraft striking the columns. At the sound of aircraft engines, crews would bail out, using the terrain for cover. After the air raids, the surviving units moved on, leaving damaged equipment on the roadsides. By autumn, losses on the Eastern Front were significant, and the number of combat-ready units of this type had dropped substantially. The Allied landing in Normandy required the transfer of German reserves to the Western Front, where batteries of self-propelled howitzers were also sent. In this theater, German units faced different tactics. American and British troops preferred massive artillery fire and airstrikes over frontal attacks. Due to Allied air superiority, movement took place mostly at night, while during the day the vehicles remained camouflaged. Enemy artillery operated with high precision, thanks to aerial reconnaissance and fire adjustment. German crews, aware of the risk of return fire, employed the tactic of quickly changing firing positions immediately after shooting. In December 1944, the Wehrmacht launched an offensive in the Ardennes, which came as a surprise to the coalition forces. In the initial stage, German troops made progress, while self-propelled guns supported tank groups by eliminating obstacles and suppressing strong points. Poor weather limited Allied air activity, which temporarily aided the offensive. However, fuel shortages brought the advance to a halt faster than enemy resistance. Left without gas, crews were forced to disable their vehicles and retreat. At the same time, on the Eastern Front, Soviet troops had approached the borders of Germany. The German command concentrated its remaining tank forces in Hungary, planning an operation near Lake Balaton to hold on to strategically important oil fields. Arriving in Hungary as part of the tank divisions, the self-propelled howitzers took up positions for the operation that began on March 6, 1945. The guns delivered intense fire, supporting armored attacks, yet ammunition resupply was difficult due to the spring thaw. The deeply echeloned defense of the Soviet troops, including minefields, halted the tank advance. Attempts to suppress the anti-tank defenses were complicated by the numerical superiority of Soviet artillery. A week later, the Wehrmacht's offensive potential was exhausted, and a Soviet counter-offensive began. During the disorderly withdrawal, a significant amount of equipment stuck in the mud or left without fuel and recovery vehicles was destroyed by its own crews or abandoned. By April 1945, the surviving Hummel self-propelled howitzers were back on German soil. Facing a massive Soviet offensive, German tank units were dealing with a severe shortage of equipment, effectively operating with just a handful of vehicles compared to their official strength. Because of the lack of fuel, the self-propelled guns were often used as stationary firing points to defend towns. Crews positioned the vehicles at intersections to fire directly at enemy armor. The 150mm guns remained highly effective, but their firing positions were quickly silenced by return fire. The surviving crews would retreat through the city streets to the next defensive lines. In Pomerania and Silesia, these SPGs were used to cover evacuations and retreats, holding back the Soviet advance on the roads leading west. Once their ammunition was exhausted, which happened fast, the crews destroyed their machines with thermite charges. The intense heat rendered the vehicles completely useless, making it impossible to even salvage spare parts. Some self-propelled guns were captured by the Red Army in working condition if the German crews didn't have time to destroy them. Recovery teams evacuated these machines to the rear for testing ground trials. With the start of the Battle for Berlin on April 16, 1945, and the fighting on the Seelow Heights, the remaining Hummels were integrated into the defensive system. They fired from positions in the suburbs at the advancing formations. The high density of troops ensured hits, but resupplying ammunition became impossible due to the destruction or capture of warehouses. Crews fired until they ran out of shells, after which they abandoned their equipment and joined the infantry. After Soviet troops broke into Berlin on April 21st, street fighting began. Left without fuel, the SPGs were used as immobile artillery points on squares and avenues. Their open-top design made the crews vulnerable to sniper fire and infantry from the upper floors of buildings. Attempts to install makeshift protection using metal sheets and wooden boards against grenades proved ineffective against anti-tank rifles and guns used at close range. By the end of April, the fleet of these machines in the city had been practically wiped out. On April 28th, in the Tiergarten area, an episode was recorded where an SPG was used against tanks breaking through to the Reichstag. During the battle, 2 T-34 tanks were knocked out, but the self-propelled gun was destroyed by return fire. The crew managed to bail out and hide in neighboring buildings. By the time the Berlin garrison surrendered on May 2nd, the overwhelming majority of Hummels in the city had been destroyed in combat or abandoned without resources. Soviet specialists found dozens of burned-out husks of these machines on the streets. Outside Berlin, individual units were used until the very end of the war. In Czechoslovakia, several self-propelled guns participated in clashes with the Prague Uprising and advancing Red Army units. On May 8th, even after the act of surrender had been signed, the final shots from guns of this type were fired on the outskirts of Prague. The crews made attempts to break out to the west to surrender to American troops, but the majority of them fell into Soviet captivity. This equipment fell into Soviet hands as war trophies, along with other examples of German weaponry. Command issued orders to gather all operational Hummel, self-propelled guns, at special collection points for analysis. Engineers conducted a detailed study of the vehicle's design, evaluating the technical solutions implemented by German specialists. The front engine layout and the use of a hybrid chassis drew particular attention. A number of units were sent to proving grounds for live fire testing to determine armor resistance. The results revealed the superstructure offered poor protection. Its armor was penetrated by 45mm shells. At the same time, specialists gave high marks to the ballistic performance of the 150mm howitzer. The service life of these captured self-propelled guns in Soviet units proved short. A shortage of spare parts and compatible ammunition made their regular operation difficult. By the end of 1945, most of the captured vehicles were scrapped, and only a few rare examples survive to this day as museum exhibits in various countries. The history of active service for this type of equipment ended simultaneously with the end of combat operations in Europe. Over 3 years of deployment, these machines were used on various sectors of the front, accompanying German troops throughout the entire campaign. Operational experience showed that these self-propelled guns were powerful weapons, capable of effectively engaging various targets. Nevertheless, design limitations, such as a small ammunition load and light armor protection, prevented the vehicle from fully realizing its potential. While effectiveness largely depended on crew skill and the tactical situation, the high performance of a single weapon system could not compensate for strategic command errors and the imbalance in resources between the opposing sides.